Good morning, friends. So we successfully completed the first topic, that is the solution topics, and today we're going to start the new topic. It's from physical chemistry, that is the chemical thermodynamics. Chemical thermodynamics. As far as the chemical thermodynamics is concerned, before going to study the details of the topic, just I would like to say some introduction about the topic, isn't it? If you consider the word thermodynamics, this word thermodynamics splits, if you split into two small words, then it is thermo plus dynamics, isn't it? Thermo plus dynamics. And the meaning of thermo in the sense heat, meaning of thermo in the sense heat, and the meaning of dynamics in the sense flow, meaning of dynamics in the sense flow, simply heat flow, simply heat flow means thermodynamics. And before thermodynamics, one more word is there, chemical. So just if I put here chemical, that is the chemical, in chemical reaction heat flow, that is the simply chemical thermodynamics is nothing but that is the heat flow in chemical processes or reactions. केमिकल रिएक्शन मध्ये किंवा प्रोसेस मध्ये होणारी हीट जी आहे ती फ्लो, हीटचा फ्लो, हीटचा मोमेंट हे पण स्टडी करणार, दॅट इज द अंडर केमिकल थर्मोडायनामिक्स. इट इज वर्ड टू वर्ड मीनिंग, बेसिक मीनिंग ऑफ द वर्ड टॉपिक, दॅट इज द केमिकल थर्मोडायनामिक्स. नाउ if you consider thermodynamics as that is the study, that is the flow of heat, isn't it? So flow of heat, if you consider the energy, well, that is a basic point, energy. If you want to define energy, yes, energy is defined as it is the capacity of body to do work, isn't it? कोणत्याही बॉडीची स्वतःची एनर्जी म्हणजे काय, तर त्या बॉडीकडून किती वर्क केलं जाते त्या वर्कवरून आपण त्या बॉडीची एनर्जी सांगतो, isn't it? That is the capacity of body to do work is nothing but energy associated with that body. In the sense, more is the work done by the body, energy associated with that body is also more. जास्तीत जास्त वर्क केलं गेलं त्या बॉडीकडून, त्याचा त्या बॉडीमध्ये असणारी एनर्जी जास्त आहे, अँड व्हाईस वर्सा मीन्स small, less is the work done by the body, less is the energy associated with that body, isn't it? So simply energy of body is nothing but capacity to do work, and different body performs different work, that is they have different energies, So what are the different forms of energies? If you consider there are different forms of energies. Okay, suppose kinetic energy is there, potential energy is there, translational energy is there, rotational energy is there, isn't it? Then mechanical energy is there, electrical energy is there, chemical energy is there, etc. And so on. There are much more different forms of energies, and all these forms of energies are interconvertible to each other. एकमेकांमध्ये हे काय होतात, interconvertible. All these different forms of energies are interconvertible to each other, isn't it? So if you take an example how they are different forms of just 3 to 4 forms of energies, how they are interconvertible to each other. Now if you consider, that is, suppose that is the, just consider a dam, isn't it? Dam, suppose, and there is water is stored in the dam. Suppose here water is stored in the dam, here it is water is stored, isn't it? High level, and this is the ground level. Suppose this is ground level. Now as water is stored in the dam, this dam, at high level, at height, okay, high level, in the sense which sort of energy is associated with that water? Yes, potential energy. It is associated with lot of potential energy associated, isn't it? Now when water flows from high level to ground level, it flows from high level to ground level. During the movement of water, during the flow of that water, potential energy ultimately converts into kinetic energy. Potential energy converts into kinetic energy. So when flowing water, moving water at high speed, before striking on the ground level, isn't it? Before striking on the ground level, if we place here turbine, where the turbine place here, rotate the turbines, and due to rotation of turbines, suppose it generates electrical energy. Then kinetic energy is converted into electrical energy. So if due to this electrical energy, suppose we illuminate one bulb, isn't it? Suppose bulb is illuminated, then its electrical energy is converted into light energy. Or suppose electrical energy is used to charge batteries, isn't it? In the sense, electrical energy is converted to chemical energy, and so on. So this is the one simple 3 to 4 cases where the energy, how they are converted from one form to another form. That is a meaning that the energy neither be created nor be destroyed. Mere it can be transferred from one form to another form. That is the law of conservation of energy. एनर्जी कधीही डिस्ट्रॉय करता येणार नाही किंवा नवीन तयार करता येणार नाही. फक्त एका फॉर्मची एनर्जी दुसऱ्या फॉर्ममध्ये आपण कन्वर्ट करू शकतो. नाउ सी हियर, पोटेंशियल इज कन्वर्ट टू कायनेटिक इज कन्वर्ट टू इलेक्ट्रिकल कन्वर्ट टू लाइट एनर्जी or chemical energy, and this chemical energy again used for further cases. Again chemical energy again converts into light energy. The torch, batteries are there. Okay. This is a simple basic concept to understand how the different forms of energies are interconvertible to each other, isn't it? Now if you define the chemical thermodynamics, simply thermodynamics is the study of energy changes taking place in physical and chemical transformations. फिजिकल आणि केमिकल ट्रान्सफॉर्मेशन्समध्ये जे घडून येणारे एनर्जी चेंजेस आहेत ह्यांचा अभ्यास करणं, ह्यांचा स्टडी करणं म्हणजेच केमिकल थर्मोडायनॅमिक्स. So simply chemical thermodynamics in detail, if you want to define chemical thermodynamics, is the branch of physical chemistry that deals with the study of energy change taking place in physical and chemical transformations. This is called chemical thermodynamics. Now as far as chemical thermodynamics is concerned, it has a wide range of applications, isn't it? In different fields of sciences, isn't it? But still it have some limitations or drawbacks. One limitation is that is the limitations. One limitation, that is the chemical thermodynamics or thermodynamics does not deals with the rates of reaction. In the sense, that is the velocity or speed of the process transformation. फिजिकल किंवा केमिकल असेल त्याचा स्पीड काय आहे, व्हेलॉसिटी काय ट्रान्सफॉर्मेशनचा, ह्याचा कुठल्याही प्रकारचा स्टडी केमिकल थर्मोडायनॅमिक्समध्ये होत नाही. दुसरा आहे दॅट इज द मेकॅनिझम ऑफ ट्रान्सफॉर्मेशन. म्हणजे केमिकल ट्रान्सफॉर्मेशन घेतलं तर कुठल्याही प्रकारचं त्याच्यामध्ये मेकॅनिझम डिटेल्ड पाथ आपण सांगू शकणार नाही. सो दीज आर द 2 इम्पॉर्टंट ड्रॉबॅक्स और लिमिटेशन्स ऑफ केमिकल थर्मोडायनॅमिक्स. So it is about introduction, chemical thermal definition, different forms of energies, law of conservation of energy, and these are the 2 limitations or drawbacks. After that, we are going to study some basic, that is the terms used frequently in this topic from here onwards. That is the basic terms used in thermodynamics. First one, that is the system. Yes, system means what? Terms used, system. So before going to study system means what, just consider a cylinder. Just consider one cylinder like this, isn't it? Suppose some amount of gas is filled in that cylinder, isn't it? Some amount of gas is filled here. Here it is suppose filled with gas, any type of gas, and it is fitted with suppose a piston. Here it is fitted with piston. Suppose it is fitted with piston, and that fitted piston is rigid, movable, and frictionless. पिस्टन जे फिट केलेलं पिस्टन, हे पिस्टन कसं असणार आहे, इट इज रिजिड, इट इज मुव्हेबल and it is frictionless. कुठल्याही प्रकारचं त्याच्यामध्ये फ्रिक्शन म्हणजे ड्युरिंग द मुवमेंट of that piston up and down in that container, in that vessel or container, there is no any sort of friction, and it is during that moment it is rigid also, means strong, unbreakable and movable, isn't it? Now like this, and suppose here gas is filled. Now if we want to study the due to moment of that piston up or down, the gaseous expansion, compression, and all these properties, if you want to study, then in this case system is our gas which is placed inside the container or beaker, and outside the system, that is this beaker, our other surrounding, other part is termed as a surrounding, so 2 points we cover here. System, it is the part of universe. System, if you want to define system, yes, system, it is the part of universe under thermodynamic investigation. Under thermodynamic investigation is a part of universe. पूर्ण युनिवर्सचा असा पार्ट की ज्याच्यावरती थर्मोडायनॅमिक्स इन्व्हेस्टिगेशन किंवा थर्मोडायनॅमिक्सचं ऑब्झर्वेशन्स आपण करणार, थर्मोडायनॅमिक्सचे स्टडी करणार आहे. इट इज द सिस्टम. सो इन दिस केस द गॅस विच इज एनक्लोज्ड इन द सिलेंडर इज द सिस्टम, अँड part of the universe here, I define here, it is a part of the universe other than system, system सोडून, except system, जे काही राहिलेलं आहे, all remaining parts are termed as surrounding. So surrounding means it is a part of the universe other than system, and system, it is a part of universe under thermodynamic investigation. Means if you accept this gas, the gas which is filled in the beaker or container, all remaining parts are termed as surrounding, isn't it? Means where we that is made observations, it is a part of the universe other than system is surrounding, and the system only gas, isn't it? And by combination of these two, system plus surrounding, it constitute universe. System plus surrounding, it constitute universe, isn't it? System plus surrounding, universe, isn't it? So basic system plus surrounding clear. Part of universe under thermodynamic investigation, system, and other than system, whatever exists, all these are considered as a surrounding, isn't it? Now if we consider the wall, that is the container जो wall आहे, हा जर आपण पार्ट कन्सिडर केला, we call as a boundary. So that's boundary is nothing but it is the separation between system and surrounding. System and surrounding मध्ये जो separator असतो, that separator we call as a boundary. That boundary may be imaginary or it real. That boundary जे आहे, it may be imaginary or it may be real असू शकेल किंवा imaginary असू शकेल, isn't it? Actually in this case, this is the glass wall or metal lining of that vessel, it is real. But if you consider the that is the gas phase, just we want to study, suppose one room is there, and if you want to analyze the gaseous, isn't it, in that room, then the boundary between the windows of room and outside, that boundary is imaginary. Just we imagine, that is the boundary. So boundaries are two types, imaginary and real. Okay, and system, surrounding, and boundary. Okay, then after that we are going to study the types of system. So there are three types of system, isn't it? There are three types of system. There is open system, closed system, and last there is isolated system. isolated system, open, closed and isolated system. Okay, now if you consider a open system, isn't it? Now open system means what? Where if just we take example first and then it is clear, isn't it? If you consider a cup of hot tea, if you consider cup of hot tea, isn't it, in open condition, just cup of hot tea in open condition, if you consider, then cup of hot tea in open condition, if you imagine here this cup of hot tea in open condition, then if you kept as it is hot tea for suppose for long time in the sense for suppose half an hour, then what happens? Yes, whether the hotness of that tea remains as it is or it becomes cool down. Yes, it becomes cool down. As it becomes cool down in the sense, yes, it exchanges heat. Hot tea exchanges its heat with surrounding, because hot tea, that is the cup मध्ये जो tea आहे, चहा आहे, it is the system and other part it is surrounding. So that tea exchanges heat with surrounding. पहिला part, it exchanges heat with surrounding, and also during that exchange of heat, water vapors also exchanges to the surrounding. Water vapors means it exchanges also matter. It exchanges matter. So we define now open system is the system where there is exchange of both. There is the heat and matter. Heat or energy and matter will cause no problem. There is exchange of matter as well as energy. म्हणजे एनर्जी आणि हीट, एनर्जी आणि मॅटर दोन्हीच एक्सचेंज होत असेल तर त्याला आपण ओपन सिस्टीम म्हणणार. सो ओपन सिस्टीम इज अ सिस्टीम विच एक्सचेंजेस बोथ मॅटर as well as energy with that of the surrounding. Now same example if you continue here, isn't it? If you consider a cup of hot tea, but now in this case if I place a lid over that cup, त्या कपच्या वरती on that cup if you place the lid, isn't it, saucer, then if you place lid, what happens? After some time, no problem, the hotness it becomes decreases, means it becomes cool down tea. So as it cool down means it exchanges only energy or heat. But if you consider the water vapors from that hot tea does not escapes into surrounding because we place lid over that hot cup, isn't it? Means there is a no exchange of matter. Yes, there is a no exchange of matter. So we define closed system is the system which exchange only energy, not matter with surrounding, isn't it? It is example of closed system. Now if you consider the isolated system, now same example, but here we put the hot tea in suppose a thermos flask. If we put hot tea in thermos flask मध्ये जर put केला आपण hot tea thermos flask, you know what happens? Yes, after some time the hot tea remains hot, isn't it? And it does not exchange its matter also. Means isolated system is a system which neither exchanges matter or exchanges, that is the energy with surrounding. Matter पण exchange होत नाही आणि एनर्जीचं पण exchange होत नाही, अशा सिस्टमला म्हणणार आपण isolated system. So it is simply types of system depending upon whether that system exchanges energy or matter with surrounding or both with the surrounding, isn't it? So it is simply we can also just tabulate it as a, just we tabulate here. Here it is the type of system, and here suppose energy, matter, isn't it? Type of system, open system, closed system, isolated system. Okay, all system. Now open system, it exchange energy as well as matter with surrounding. Closed system, yes, it exchange only energy, not matter with surrounding, isn't it? And isolated system, it neither exchange energy nor matter with surrounding. So this is a simple table that will help to remember whether it exchange energy or matter with surrounding or not, isn't it? So depending upon that, we classify the system into 3 types. Okay. Now after that, we are going to discuss the properties of system. Simply properties of system. Properties of system. Properties of system. Now we classify it depends upon whether that property depends upon amount of matter present in system or not. Whether the magnitude or values of this property whether depends on amount of matter present in system or not. सिस्टीम मध्ये असणाऱ्या अमाउंट ऑफ मॅटरवरती त्याची व्हॅल्यू अवलंबून आहे किंवा नाही, ह्या बेसिसवरती प्रॉपर्टीज ऑफ सिस्टीम इज क्लासिफाइड इनटू 2 क्लासेस. फर्स्ट वन, इट इज द एक्सटेन्सिव प्रॉपर्टी. एक्सटेन्सिव property and second one, that is the intensive property. Yes, as far as extensive property is concerned, extensive properties are the properties of system whose value, extensive property of the property of system whose values depends upon amount of matter प्रेझेंट इन सिस्टीममध्ये असणाऱ्या अमाऊंट ऑफ मॅटरवरती जर एखाद्या सिस्टीमची व्हॅल्यूज अवलंबून असत असेल तर ती जी काही सिस्टीमची प्रॉपर्टी आहे, दॅट्स प्रॉपर्टी सिस्टीम वी कॉल ॲज अ एक्सटेन्सिव्ह प्रॉपर्टी. दी एक्सटेन्सिव्ह प्रॉपर्टी जे व्हॅल्यू जर बघितला, इट इज द मास, एक्झाम्पल मास, व्हॉल्यूम, देन हीट कॅपॅसिटी, number of moles. These are some examples of extensive property. So remember well, extensive property म्हणजे काय? एक्सटेन्सिव्ह प्रॉपर्टी म्हणजे सिस्टीमची अशी प्रॉपर्टी की जी प्रॉपर्टी त्या सिस्टीममध्ये असणाऱ्या अमाऊंट ऑफ मॅटरवरती अवलंबून आहे. जर त्या सिस्टीममध्ये अमाऊंट ऑफ मॅटर कमी जास्त केला तर डायरेक्टली इट अफेक्ट्स द व्हॅल्यू, मॅग्निट्यूड ऑफ दॅट व्हॅल्यूज, प्रॉपर्टीज. That property is called as a extensive property. Opposite to that of the extensive property, intensive property. That is the intensive properties are the properties of system whose values does not depends upon amount of matter present in system. सिस्टीममध्ये असणाऱ्या अमाऊंट ऑफ मॅटरवरती जर त्याची व्हॅल्यू अवलंबून असत नसेल तर त्याला म्हणणार आपण इंटेन्सिव्ह प्रॉपर्टी. ह्याचे एक्झाम्पल जर बघितला, इट इज द एक्झाम्पल्स ऑफ सच आर द बॉइलिंग पॉईंट, मेल्टिंग पॉईंट, रिफ्रॅक्टिव्ह इंडेक्स, viscosity, isn't it? Refractive index, viscosity, boiling point, melting point. These are the some examples. Again, there is the pressure, temperature, etc. Means if you consider the melting point of suppose 1 gram substance has specific, and same substance if we melt in 1 kilogram, its melting point also same. Means amount changes but its property remains same. Intensive property. But if you consider it is the volume or mass, suppose it is the mass of suppose 2 kilogram, or volume of suppose 1 kilogram gas has fixed volume, and same gas if we change the amount, that is the 2 kilogram, its volume changes. So that is the, by changing the amount of matter present in system, if that values changes, it is extensive, and it remains same, it is intensive. What is the basic difference between extensive and intensive? Make question asks, classify the following property into extensive and intensive property. classify the following properties of system into extensive and intensive property. Just one basic thing, just I would like to tell you how to know extensive and intensive, whether it depends or not depends, isn't it? Just if you consider the extensive word here and intensive word here, and just from starting words of the word alphabet of the extensive and intensive, just check where n comes first. Where n comes first. In extensive, E-X-T-E-N. 1, 2, 3, 4. Fifth letter is n, isn't it? But in intensive, second letter is n. So second letter in the sense not depends. Second letter first comes, it is not depends. So that is the does not depends on amount of matter. Intensive depends on amount of matter. Extensive, isn't it? Okay. Now we're going to the next point, where is the state function. State function. As far as state function, before going to study, now see here, one cylinder is there. Suppose cylinder is there, and suppose that cylinder is filled with some amount of gas. Suppose it is filled with some amount of gas. It is fitted with same, that is the weightless, frictionless, rigid, movable piston. Suppose it is fitted with weightless, rigid, movable piston fit केलेला. And suppose it carries some weight. Suppose carried some weight over that piston. Now, suppose the gas which is enclosed in the cylinder, if that gas has pressure P1, volume V1, and suppose temperature T1. Okay, the gas which is enclosed in that cylinder, if that gas has pressure P1, maybe I consider atmosphere, volume V1, dm cube, temperature T1, isn't it? Now, as long as these properties remains same, in the sense we say that is the system has fixed state. System has fixed state as long as these values remains same, isn't it? Now, that is, we specify the overall system by specifying the values of pressure, volume and temperature. This pressure, volume, temperatures which specify the given state of system is called as a state function. Is called state functions. Simply that pressure, volume, temperature we call as a state functions. Simple. Now, if you consider we want to change the state of system, suppose it is initial state. If you want to change the initial state of system, isn't it? Just by removing the weights, over that piston. So if we remove the weights over the piston, yes, if we remove the weights over the piston, isn't it? If we remove the weights over the piston, then what happens? Yes, suppose volume changes as weight removes from that over piston, so automatically gas expands. So as gas expands in the sense, yes, gas expands in the sense volume increases, and suppose volume increases, suppose V2 dm. As volume increases, yes, according to Boyle's law, its pressure decreases. Suppose actually decrease pattern, actually here one symbol is written, I write here 2, but it decreases, not P1 to P2 in the sense, not it increases, it decreases. Suppose temperature remains constant T1. Now, this conversion from initial to this, suppose this is final state. Now we specify the final state of system by specifying the pressure P2, volume V2 and temperature T1, which is different from the initial, state. So this is the new state functions for that system in new state, So actually state functions are these are the properties of system which depends only on current state of system, and not on path followed to reach that state. Means what? Yes, state functions, these are the properties of system which depends only on the current state of system and not on the path followed to reach the system. Now here just you by expansion volume increases, isn't it? Volume increases but by pressure decreases. But whether the pressure decrease जो केलेला आहे तो pressure decrease इथून इथपर्यंत pressure decrease वर आहे. Suppose here pressure, suppose just I put here value, suppose 2 bar, and suppose here pressure becomes 1 bar. Then this change from 2 bar to 1 bar, whether it is from 2 bar to 1 bar or suppose it is from 0.8 bar to 1 bar, म्हणजे 2 बार कडून 1 बार कडे कमी प्रेशर केलं किंवा 0.8 बार कडून 1 बार कडे प्रेशर वाढवलं. This path is not important. This path is not important. What is important? Current position of that system. Current position of that system. Such functions are called as state functions. Such functions are called as state functions. So remember well, state functions are the properties of system whose values depends only on the current state of system and not on the path followed to reach that particular state. Isn't it? Okay. Now next one point, that is the thermodynamic equilibrium. Thermodynamic equilibrium. What is thermodynamic equilibrium? Now see, again see, same diagram. Just during this topic, same diagram we have to draw many times. Suppose a cylinder encloses some amount of gas which is fitted with frictionless rigid movable piston like this. Okay, carries some weight. And this gas is enclosed, isn't it? Gas is enclosed. Now suppose this state of system is specified by state functions. State functions already we studied. Suppose this position has state functions, pressure P1, volume V1, and temperature suppose T1. Now as long as the piston has fixed position, that piston has fixed position means it is unmovable, remains constant piston. It does not move in upward as well as downward, remains at fixed position. As long as piston has fixed position, in the sense these state functions remains same for that system. But as soon as if piston moves in upward or downward direction, then what happens? The pressure, volume and temperature going to changes in small amounts, isn't it? So as long as piston has fixed position, these properties remain same, then we say that this system is under thermodynamic